So for the 4 people who are gone today, hopefully they're watching this video this afternoon, or tomorrow, or tonight, or something. But like I said to the most of you who are here, if you have 2 points of data, you have them all. You have all 6. So 8, one less person. Cool. Okay, so if you have Vx or Vy, you have V, theta, all these things, and then of course time, if you have any 2 points of data, you have all of them, because our formulas allow you to find all of them. Okay. Now for gravity, we're going to go ahead and use -10, just because it's easier than using -9.8. Okay. Any questions before we begin? All right. So our first Spud data, we have flight time, which is going to be T max, and we have theta. What was the T max for our first Spud?
235.
235? 2.35 seconds. And what was our theta for our first Spud? 56 degrees? All right. So how can I use this information and start extracting out critical data from the flight time and the angle? Melissa?
Well, you can find the time for when it gets to the highest point, right? And then can't you use that to
Absolutely. You can do exactly those things. Yeah, so she said you can find the time to get to the highest point. That's exactly right. So if we wanted to know how long it took to the highest point, if we ignore air resistance, we have to remember that what goes up must come down. So it takes half the time to go up and half the time to come back down. So if it took 2.35 seconds to hold the whole distance, can we round this up to 2.4 just to make the math easy? Let's just round it up to 2.4. So if it took 2.4 seconds to go the whole distance, then how long did it take to get to the highest point? 1.2 seconds. So the T top is 1.2 seconds because the T max was 2.4. So the T top was 1.2 seconds. That's great because that information gives us what variable? Vy, gives us Vy. So we remember that Vy is going to be given to us by AT. If it takes 1 second to stop, at what vertical velocity was it launched? 10 meters per second. If it takes 2 seconds to stop, by what vertical velocity was it launched? 20. See how this works? Because gravity slows things down at 10 meters per second. So if it takes 8 seconds to stop, then it went up at what velocity? 8. Okay, so that gives us this information. This says, oh, well if T top was 1.2 seconds, that means that our Vy was what? 12. Yeah. 1.2 times 10, or 12 meters per second. Again, if you like units, then meters per second equals meters per second squared times seconds. Acceleration times time gives us velocity. Cool? Okay, give me a thumbs up if that makes sense to you. All right, so cool, we got Vy. That's handy. We got some options now. We can do a couple things. What would you like to do next? I'm sorry? Make a right triangle. Okay, cool, so make a right triangle. So a right triangle has a hypotenuse and a leg and a leg. This is Vy, this is Vx, and this is V. And we got some options here. We know this is 56 degrees. So what would you like to solve for?
Shouldn't it be switched?
Yes, those should be switched. Thank goodness you're here. Definitely have one day. So this should be Vx, and this should be Vy. Sorry, yeah. So what would you like to solve for? V of x? Okay, so solve for V of x.
So Vy was 12, right?
The angle, the relationship here would be the tangent of theta. Tangent is opposite over adjacent, which would be Vy over Vx. Make sense? If you like doing other things, then you can also realize that Vy equals V sine theta. You can use those relationships. So this will allow you to find V and Vx. We're going to find Vx and V. You can basically pick and choose, as long as the numbers make sense to you. Remember, after the calculator spits out a number, ask yourself, does this number make sense? Can a hypotenuse ever be smaller than a leg?
No.
No. If you had an angle that is larger than 45, what should be bigger, the Vx or the Vy? For an angle larger than 45. The Vy should be bigger, yeah. For an angle smaller than 45, the Vx should be bigger. So go ahead and solve for Vx and V. Anyone getting flummoxed? You can help me yell at them? I mean, help you?
Yelp.
Will you yelp at you?
Please don't yell at me.
Okay.
I don't need any reports.
Do you need help? Okay. Well,
I'm
not seeing a lot of work on your paper, so I'm assuming the answer is yes. All right. So you've got your Vy, and that came from your time top. Time top comes from total time. Now realize that your Vy is this leg here, and you can solve for the hypotenuse or the Vx. So write in the relationship that Vy equals V cosine or V sine theta, Vx equals V cosine theta, or you can use the tangent, and then arrange the equation so you have the thing you want.
Wouldn't the Vy be 12 meters?
It is, yeah. Vy is 12 meters per second. And we're going to use the Vy to determine what the V is or the Vx is. Actually both, what the Vx and the V is.
Well, no, but for the right triangle, it's 12 right
12.
there. And then,
Yep, yeah. So now you can use trigonometry to solve for your Vx and your V.
I understand that part now.
Well, show me. You need a calculator. I have those. I have calculators.
Thank you.
Anyone else need a calculation device? Live. You're like, I couldn't do anything without a calculator in front of me. Well, we can fix that. We have calculators. Anyone else need a calculation device? Anyone else? All right, so now you are well equipped. You have pen, you have paper, you have calculation device. You can plug the numbers in.
Big brain.
Use that big brain. Rise up and get your math on. Make little Moses proud. Not right.
That's not right.
Okay, some of you are already moving on to the next couple steps. So Those who got a Vx, what did you get for Vx? 8.1? Sounds good, I like that. 8.1 meter per second. And then the hypotenuse V was what? 14.5?
Yes.
Alright, sounds good. Okay, cool. So we got an angle of 56 degrees. Our Vy is in fact larger than Vx, and our hypotenuse is bigger than both of them. Yay! Okay. So again, if you went for the Vx route, and you had V and Vx and Vy, you could use the Pythagorean theorem to find V, because it's a right triangle. You could also find Vx from V and Vy, okay, by using the Pythagorean theorem, or you can use tangent and sine. Your options are numerous when you have a right triangle, as long as you draw your diagram and understand where everything is. Always draw a diagram. Physics, diagram drawing, for mathy people. It's art for math people. Okay, give me a thumbs up if you understand where these numbers came from. Wave your hand around if you want to talk about it some more. Okay, so what's left? We got a dx and a dy. We got our time top, we got our time max. So now we need a dx and we need a dy. For our dx and dy, we're going to go ahead and say maximum height and maximum range, but understand that dx and dy can be found for any point in the flight, any point in all in the flight, because they both have time. Okay. They both have time present. Dx has one time, and dy has two times. One of them is squared. What is the formula for dx? dxt, yeah. dx is just dx times t, and dy is dy naught t, dy naught t plus 1/2 at squared. So go ahead and solve for dx and dy for Spud number 1.
The maximum height and the maximum distance?
Yes, yeah, we're going to find max height, dy max and dx max. But understand that you have the ability to put in any time you want in there.
Wait, so for dx, do we plug in 2.4 for t?
Yes. And hopefully if you plug in 2.4 for t for dy, you get 0. Hopefully you're like, I ran it back on the ground. Hopefully. If we did it right, that's what you'll get.
The VOT is the initial velocity, right?
Correct. In the vertical direction.
Oh, vertical.
In the vertical direction.
That would be
Both.
y?
Yes.
Okay.
Okay, so some of you have already moved on. So what did we get for dx? 19.44? Okay. 19.4 meters. Again, this is meters per second times seconds equals meters.
I was plugging in the dy calculation and I put in 2.4, but then the end result I've been getting 57.6.
Oh, you remember that a is negative 10?
Negative 10, there we go. That's fine.
So based on that information, 28 would be the longest range. Is that right? How far did it go at 2.4 seconds?
Yeah.
Oh, sorry, dy. Maximum height, sorry, maximum height. 1.2 seconds. forget everything I just said. All right, so the maximum range is 19.4. How high did it go at 1.2 seconds?
7.2.
7.2? 7.2 meters. Okay, cool. So, again, for the maximum height, you're going to put in T-top. T-top. And for maximum range, you're going to put in T-max. Does all this stuff make sense? Okay. Why don't you go ahead and do Spud number 2, and I will start drawing it out, and then we will compare your answers to my answers. Was this the high angle one or the low angle one?
7.
Okay.
We just put this
Yes.
I just had a question on
Sure.
the DY. So how did you get 7.2?
For the DY?
Yeah.
We put in the time to the top of 1.2. So we did 12 multiplied by 1.2 plus 1/2 negative 10 1.2 squared.
It's negative.
Wait. I'll plug you 32.
Oh, there we go.
What was the angle and flight time on the second Spud?
I was told it was 70 degrees. Is that right? And T-max. What was the flight time for the second Spud? 4.54?
4.5 seconds.
4.5 seconds. Right. balloons don't matter.